Let's start with this problem. This is 2015 AMC 10 problem number 24. Let's try to understand this problem first. So around the ant walks on the coordinate plane. So we have to draw a coordinate plane. So this is my x-axis. This is my y-axis. He starts at origin P0. So this is my origin P0, 0, comma 0. Facing to the east. So this is my north, this is south, east and west. It walks 1 unit and arrive at P1. So it's walking 1 unit here and reaching to P1 1, comma 0. For n is equal to 1, 2, 3 right after arriving at Pn. For us, n is equal to 1, it is starting from P1 and reaching to Pn plus 1 is P2. If Aaron can turn 90 degrees to left and walk 1 unit unvisited point Pn plus 1. So for here, he is facing east. So for this left side is this. He can turn 90, yes. He can walk 1 unit, yes. And he can reach to unvisited point, yes. There is no visited point. See, this is my visited point. I have already visited P0. I have already visited P1. So this is my new point. So yes, I can visit here. This is my P1, comma 1. So again, it takes turn, left turn. So for this north, south, left turn would be this side. And it walks 1 unit and reach to unvisited point again. So this is called P3. This is 0, comma 1. Now it's facing towards west. So again, if it takes 90 degrees to left, it will reach to P0. So that is your visited point. So that's why other condition is there. Otherwise, if he is not able to reach to unvisited point, then he walks 1 unit straight. So we don't want to visit to the visited point. We will not take 90 degree turn. Rather, we will move 1 unit ahead and reach to P4. That point would be my minus 1, comma 1. So it reaches to P4. Now after this, again it takes left turn and reach to P5, which is my minus 1, comma 0. Again, if it takes turn 90, it will reach to P0, which is a visited point. So Arun doesn't want to visit the same point. So it will go to otherwise condition and it will take 1 unit ahead and will reach to P6, which is my minus 1, comma minus 1. And similarly, it can move towards right and reach to my, this is P6, P7 is 0, comma minus 1, taking 1 more unit to P8, which is 1, comma minus 1. If it takes turn towards left side, it will again end up reaching visited point. So it doesn't want to go to P1. Rather, it will go straight 1 unit to P9, which is 2, comma minus 1. And now it will keep going on. It will reach to P. This is P9, 2, comma 0. P10. This is 2, comma 1. P11, 2, comma 2. Now we need to find where my point would be when we have P2015. So in each step, it reaches to 1 point. So it should start from P0, we starting from P1 to P2 in one step. In second step, we are reaching to P3. In another one step, we are reaching to P4. So we want to find out after 2015 step where we would be in Cartesian plane. Okay. So now let's see, we can see some pattern here. We can take some reference points like I reach to 1, comma 1 point in 2 steps. So I'll change the color of my pencil to some red color and I'll see this is my 1 unit and this is my 1 unit. So in 2 steps, I am reaching to 1 comma 1. I can take another reference point, say suppose minus 1 comma minus 1, minus 1 comma minus 1. I am reaching this. This is 1 unit. This is again 1 unit. So this is total 2 units. This is also 2 units. Total 4 units. So I'm reaching in 2 plus 4, 6 steps. Again, I can go back here and see where I do reach. So my 2 comma 2 is I am reaching in 2 plus 4 plus, let's count. So this is 1 plus 1 2 plus 1 3, and here also 4 and 5 and 6. So we are reaching in 6 steps. Maybe I can make the pattern minus 1 comma 1, I will reach in 2 plus 4 plus 6 plus 8 steps. But we need to verify few of the steps. To reach to this point, I have to, let me change my color of my pencil, black, and I am reaching to this point. This is my minus 2 comma minus 2. Let me change again the color of my pencil to red. Let's see. So this is my 1 unit, 1 unit, 1, 1. So this is total 4 units. Similarly, this is my 1, 1, 1 and 1. Again, this is 4 units. So I'm able to verify it's taking 8 extra steps. So I can see some pattern. I like minus 1, 1 minus 1. Oh, sorry, this is minus 2 comma minus 2. I can see here, this is my last term is 4 into 1. So I see 1 here, I see 1 here. This last term is 4 into 2. My last term is minus 2. So I can make a rule. If I reach to minus k comma minus k, I would take 2 plus 4 plus 6 plus 8 and dot 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 4 into k steps. So how many steps would be? I want to just roughly calculate if it is reaching to 2015. So I take common of these steps. So I get 1 plus 2 plus 3 plus 2k. This is my natural number of sum 2k. I know the formula n into n plus 1 by 2. I can plug in 2 into 2k. Here n is 2k. 2k plus 1 divide by 2. So that would be, I cancel out 2. So if this should be less than 2015. It might not be precisely 2015, but less than 2015. So I want to roughly estimate this. So if I discard this, roughly 4k square is less than 2015 and k square is less than 503. So I can see which square is this. 20 square is my 400 and 25 square is my 625. So my k would be between these two. I can experiment. So my k would be coming out to be 22. So if I calculate 22 multiplied by 22 is 4 into 121 is 484. Yes, 484 is less than 502. 503, sorry. So I can start with k 22. So after, if I plug in k value of k as 22 in this, I would get at minus 22 minus 22, I would be covering steps 2 into 22 into 2 into 22 plus 1, that is 44 into 45. So that would be 1980. So if k value is 22, we are reaching at minus 22 comma minus 22 point, and steps we have covered so far is 1980. We want to know where we would be after 1025 steps. So let's see how many steps are left. I subtract 1980 from 2015. I get 35. So as per the question, it will keep walking 1 unit at a time to the right direction until it reaches unvisited point. So I want to know after 35 steps where we would be. So I see my y coordinate will remain same. So I write minus 22 as y coordinate. For x coordinate, I will add 35 minus 22 plus 35 is my 13. So I get my 13 comma minus 22. So that is my answer.